This is section 5.2 for geometry. Uh, pretty straightforward صراحة, كله the same formula. It's this one formula for the area. I think all of it. Yeah. Uh, the area of, I think this is in most people's prep lists. Triangle ABH over ABC is K over 25. What is it? The area, the ratio of the area, I put it here from the last recording. The area of triangle 1 over the area of triangle 2 is the side 1 over side 2 squared. Okay, so let's see. They want triangle ABH. ABH is over here, and we don't really have any side other than 6. So it's going to be 6 over the corresponding side. It has to be the corresponding side. You can't just take any side. So this is the hypotenuse because this is the right angle, yeah? We have to take now the hypotenuse of the other triangle because it has to be corresponding. For ABC, you have to say ABC. You can't just take any side, we have to take the hypotenuse. The right angle is over here. For the hypotenuse is over here. We need to find this side. It's not given, but we can find it. Pythagoras theorem, 6 squared plus 8 squared. You get 100, square root 100, you get 10. Okay, for this side is 10. That will be 6 over 10 squared, which is 9 over 25. Question 2, it's the same exact thing, but they just changed the numbers. Honestly, I'm not going to say I'm going to see them bringing this written, but I can definitely see them bringing this question in the exam. Okay, computer at least. SBL over KBS, SBL again, this one here, take 8 over the other triangle. You have to take the hypotenuse because we took the hypotenuse for SBL. That means you have to take for other triangles. This triangle here, they said KBS, opposite side. We have to find it, so it will be 8 squared plus 15 squared. You get 289. Square root 289, it's 17. For 8 over 17 squared, you get 64 over 289. Question 3. Okay. For the circle, okay, the sides you take that are corresponding are the sides that are beside each other. Okay, it won't be 6 corresponding to 7. No, it's going to be 5 corresponding to 7. Okay, the proof for this actually comes from the inscribed angles. If you remember in term 1, this angle over here inscribes this arc, and this angle over here also inscribes this arc, meaning this side is corresponding to this side. Okay, and that's just the proof, but if you just want to memorize, the corresponding sides are the ones beside each other. And I see this question coming also in the exam. We want 2 corresponding sides from CPB, which is this one over here, okay, and APD, PAD, whatever. Okay, the corresponding are 5 and 7. For CPB, which is 5, APD is 7, for 5 over 7, and it has to be squared. Okay, 25. Question 4. DEF, similar to QPR. DF is 10, DE is 5, EF is 8, RP is 16. Area of QPR over DEF. Okay, we need 2 corresponding sides, QPR and DEF. What side do we have given? We have RP. RP over here, yeah? What corresponds to RP? EF. What do we have EF? Yes, we do. Okay, for QPR 16, EF is 8 squared, you get 4. Question 5. This time they gave you these sides A, B, C, C, D, E, but pay attention, they're saying perimeter. For perimeter, it's just side over side. There's no square for perimeter, it's only side 1 over side 2. For the perimeter of A, B, C, D, E prime, what we have given, we have A, B prime. So what corresponds to A prime, B prime? Obviously AB. Okay, for A prime, B prime, which is 48, over AB, which is 6, you get 8. Now that's it for 5.2. This is the 5.3 recording. It's all about the length of the arc and area of the sectors and the arcs. So one formula you need to know. I'll say two formulas. We'll put them here. The length of an arc is theta over 360 times 2 pi r. Theta is the angle يعني this of the arc. The area of a sector is theta over 360 times pi r squared. Circumference equals 2 pi r. Area is pi r squared. Okay, let's start. The length of arc AC. So they want the length of this arc, yeah? You need the angle. They said the radius is 9. You need the angle if you want to find the length of the arc. If they give you a question like this, I'm going to give you the formula to find the angle. It's 180 minus this angle over here. So in this case 60. So the angle of the arc is 120. The proof for this comes, this is OA, OC. Now we want this central angle, right, for the arc. How you find it? It's actually, this is a quadrilateral over here. They probably won't ask for the proof. This angle is 90 because the tangent is perpendicular to the radius and also this. So 360, is the total angle minus this 90 minus this 90 minus this 60, and you get 120. You'll always have minus 90 minus 90. The formula can be simplified to just 180 minus this angle over here. Okay, to get the angle of the arc. المهم, you get 120 as the angle. We want the length. The length is theta over 360 times 2 pi r. They want you to keep it in terms of pi, but let's not use pi in our formula. So 120 over 360 times 2, we cancel pi out, times 2 times r, so 9. And you will get 6. Okay, here pay attention. This is not the central angle, okay, because it's not in the center. It's obvious it's not in the center. It's moved to the left. You need the angle for these arcs. So they said this arc is x degrees, this arc is 3x degrees. From term 1, okay, there was a formula. Whenever you have these two outside arcs and then the angle in the middle, okay, let's call this arc 1 and arc 2. The formula was arc 1 plus arc 2 over 2 equals the angle in the middle. So just call it center. So in this case, this is the formula. Remember when you used to have a circle like this, and this, and you have 70 here, you'd have 80 here. In the middle, it would be 75. This was the formula. المهم, that means here x plus 3x over 2 equals 60. X plus 3x is 4x. 2 times 60 is 120, X equals 30 degrees. Okay, so that means this arc here is 30 degrees. This arc here is 3 times x, so 3 times 30, so 90 degrees. Now we can solve, since we know the length, the angle for each arc, 30 and 90. What is AD gonna be? The length of it is gonna be 30 over 360. They want to keep it in terms of pi, so just keep it times 2 times the radius, which is 60. Because it's theta over 360 times 2 pi r. We're canceling out pi because they want it in terms of pi. You're going to get 2 times 60 times 30 over 360, you get 10. The length of BC. BC we said is 90 degrees. That will be 90, again in terms of pi. 90 over 360 times 2 times 60. You'll get 30. Question 2. Shaded area. This was in an AMS quiz. They said the radius is 35. They want the shaded area. Look, نحن we know how to find the area of the sector. The area of the sector is this whole thing. But they want the area of the shaded area. If we want the shaded area, it's gonna be the whole thing, the sector, the area of the sector, the area of the shaded equals the area of the sector, which is the whole thing. Okay, that's the sector, minus the triangle, right? Minus the area of the triangle. How do we find the area of the sector? We know it's theta over 360 times pi r squared. It was here in the formulas. Area of a sector. Theta over 360 times pi r squared. Let's find the area of the sector first. They're saying use pi as 22 over 7. Theta, we said, is 90 degrees because the arc is 90 degrees over 360 times 22 over 7. If you use it as a decimal, you're going to get it wrong. They're telling you use it as 22 over 7 times r squared. So 35 squared. What do you guys let me see? You get 962.5 minus the area of the triangle. The area of the triangle is very simple. This is the base, 35. This is the height, also 35. So base times height over 2, so 35 times 35 over 2. And you get 350. Yep, 350. Question 3. The area of a circle whose circumference is 12 pi is k pi. They want the area. They said the circumference is 12 pi. They want the area. The area is pi r squared. We need the radius, yeah? Type. How can we find the radius? They gave us the circumference. You know, the circumference is 2 pi r. 2 pi r equals the circumference, which they said is 12 pi. Cancel pi and pi. Divide by 2. Divide by 2. You get r equals 6. Can I find the area? Yes, I can. Pi times 6 squared, which is 36 pi. They want it in terms of pi, but the answer is just 36. Question 4. Okay, this one's a bit trickier, but you have to understand it, okay? They want the radius of the shade, they want the area of the shaded region. We can find the area of the circle, and we can find the hexagon, and then subtract them, and you'll be left with these small shaded bits. So the shaded here is equal, to the circle minus the hexagon. It's not a formula, you just need to understand. The circle, how do you find the area of the circle if we have the radius? It's going to be pi. They said use pi is 22 over 7. So 22 over 7 times 7 radical 8 in brackets squared. Okay, because it's pi r squared. Minus the area of the hexagon. The area of the hexagon is the apothegm times the perimeter over 2. They gave you the radius of the circle 7 radical 8. The radius of the circle is this, yeah? Okay, or this. Is this the apothegm? No. This is what the apothegm is. So what they gave us is the radius. So they technically gave us a side, because the radius of the circle in a hexagon is actually the side. Can I find the apothegm if I have the side? Yes, I can. The apothegm is s radical 3 over 2, remember? So 7 radical 8 times radical 3 over 2. And you're gonna get 7 radical 6 over here. Let me make sure. 7 radical 8. Oh, 7 radical 8. Yeah, you get 7 radical 6 as your apothegm. For your apothegm, 7 radical 6 times the perimeter. The perimeter is 6 times the side, right? For a hexagon. We know the side is 7 radical 8. So it's going to be 6 times 7 radical 8. For 6 times 7 radical 8 over 2. Okay, if you put this in a calculator, you're going to get a decimal. Okay, for my advice is multiply first the numbers. 7 times 6 times 7. Okay, then multiply the radicals. So 7 times 6 times 7. Hold up, 7 times 6 times 7. It's 294. For 294 times radical 6 times radical 8 over 2. This is just so your calculator gives it to you as a proper number, not a decimal. Radical 6 times radical 8 Hold up, radical 6 times radical 8 is 4 radical 3. For 294 times 4 radical 3 over 2. Again, if you put 294 times 4 radical 3, you get a decimal. Okay, if I just put it 294 times 4, which is actually 1176. And you still have that radical 3 left over 2. Okay, you have to divide 1176 and 2. You're gonna get 588 radical 3. That's for the area of the hexagon. So now we have the area of the circle, which is 22 over 7 times 7 radical 8 squared, minus the area of the hexagon, which is 588 radical 3. If you put this on a calculator, you get 1232, and this is going to be minus 588 radical 3. Okay, that's it. You keep it like this because they said something minus something. Okay, if they ask for the final answer, then you actually have to put it in a calculator. Question 5. What's the area of the shaded region? Again, it's going to be, in this case, the whole thing, which is the square. It's going to be the square minus the circle to get these shaded regions. The area of the square, if the radius is 35, okay, you know the square is side times side for the area of the square. Can I find the area of the square? If this is 35. So if this is 35, that means what's this? This is going to be 70, because 35 is going to be 70. So now I know that the side is 70, and this is also going to be 70 because it's a square. 70, 70, 70, whatever. So the area of the square is going to be 70 times 70 minus the area of the circle. What's the area of the circle? It's pi r squared. So 22 over 7, because it's pi, they're saying use pi, is 22 over 7 times the radius 35 squared. The radius is 35, and you get 1050. Okay, all I did was, this was 35, I doubled it to get the whole side, so 70. This is also 70 because it's a square, huh? And then I found the area 70 times 70 minus the area of the circle, which is pi r squared, and I get the shaded region. Question 6. In this case, they want the shaded region. Very simple. The shaded region, if this is 90, the non-shaded is 90. How much is the shaded? It will be 270. Why? Because 360 minus 90, 270. So can you find the area of the sector? Yes, you can. 270 over 360 times pi. Well, they want it in terms of pi. Let's keep pi out of the equation. Times r squared, so 12 squared. And you get 108. Question 7. The area of the sector with central angle pi over 2 is 16 pi. What's the rate? Okay, أول شيء central angle pi over 2, that means 90 degrees. Because you know pi is 180. Yeah, pi over 2 يعني 180 over 2, which is 90 degrees. So the area of a sector with central angle 90 degrees is 16 pi. What's the radius? What's the formula for the area of a sector? It's theta over 360 times pi r squared. This equals 16 pi. أول شيء let's substitute. Theta we said is 90 degrees. So 90 over 360 times pi r squared equals 16 pi. Let's cancel pi with pi. Okay, 90 over 360. Let's divide by 90 over 360 on the other side. You're gonna get 64 on the other side. So r squared equals 64. Because 16 divided by 90 over 360 is 64. How do you find r? R equals radical 64, which is 8. That's it for 5.3. Thank you so much for watching, and good luck.